Welcome back. In the previous video on hydrogen bonding, I did brought up the idea of three specific elements when they are in direct connection to hydrogen can exist a special property called hydrogen bonding. And what are those? So the three elements are nitrogen, fluorine, and oxygen. Okay. Now, just because a molecule contains nitrogen and hydrogen does not automatically lend itself to hydrogen bonding. Okay, the criteria for hydrogen bonding is that the nitrogen is directly attached to hydrogen, so is the fluorine is directly attached to the hydrogen, and the oxygen is directly attached to hydrogen. I mean, the molecule could be the size of this entire screen of this computer that I'm recording, or it could be the size of a nib of a pen. Okay, doesn't matter how big the molecule is, but if the molecule contains an arrangement in which the hydrogen is directly attached to the nitrogen, the hydrogen is directly attached to the fluorine, the hydrogen is directly attached to the oxygen, that means those molecules can exhibit hydrogen bonding. Okay, now let's compare, for the purposes, let's compare molecules CH3OH and molecule 5, which is CH3OCH3. Okay, now you will learn more about this in organic chem, but for time being, let's say that this is a alcohol. This right here is a alcohol, and this right here is an ether. That's not the focus of this particular topic. The focus here is that when we write, I'm going to switch colors again here. Okay. When we write this particular way, what that means is that the hydrogen is directly attached to the oxygen. Okay. When we write this way, there is hydrogen in the molecule, okay, but it's not written right next to an oxygen. Okay, so these are two different aspects. Okay, here the hydrogen is directly attached. Here hydrogen is present in the molecule, but it's not attached directly to the oxygen. So this one contains hydrogen bonding. This one does not contain hydrogen bonding. Okay, what is the larger implication of hydrogen bonding? Okay, we have learned colligative properties, right? So let me write a little statement here. The statement would make more sense. So say if we compare these two molecules, okay, this contains hydrogen bonding, this does not contain hydrogen bonding. Okay, one has, let's say I dissolve both 1 and 5 in water. Okay, one will have lower vapor pressure. Again, we're speculating, and usually that the speculation is true, compared to, see, number 1 will have lower pressure compared to number 5. What does that mean? Number 1 will have higher boiling point compared to number 5. So the lower the vapor pressure, lower the boiling point, right? Now, I have some examples here. So let's say we have number 1, okay, which is CH3OH, and then we have number 3, where I have ethylene glycol, which is what you find in an antifreeze. And then you have number 4, which is glycerol, which could be used as an artificial tear-producing agent. So I'm going to switch colors here. What I am trying to do right here is, I guess I could use black. Okay. If you note, if I ask you an hypothetical question, if all these 3 molecules were to be dissolved in 3 separate beakers, and I ask you which one would have a higher boiling point, you see that this one has 1 hydrogen bonding. How do I know it's 1 hydrogen bonding? Well, there's only one O which is directly attached to the hydrogen, just like here. Okay, like here. We have 1 hydrogen bonding. Here we have 2. There's 2 instances where a hydrogen is directly attached to your oxygen. Here, there's 3 instances where a hydrogen is directly attached to the oxygen. So this one has 3 hydrogen bonding. This one has 2. This one has 1. So that means the one with the most hydrogen bonding, okay, most hydrogen bonding will have the highest boiling point and the lowest vapor pressure. Keep in mind, vapor pressure is directly related to boiling point. Okay, the lower the vapor pressure, the higher the boiling point. The higher the vapor pressure, lower the boiling point. Okay, now, so if I ask you just a general question, okay, now water is also, you know, if you remember from Chem 170, water is written like this. Okay, so essentially it's got 2 hydrogen bondings. The 1 oxygen is shared by 2 hydrogen, which leads to 2 hydrogen bonding sites. Okay, so the only molecule on this list that does not have hydrogen bonding is this. Okay, which one does have hydrogen bonding? They all do. This one does, 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 and this one does. Okay, because in all the cases, the hydrogen is directly attached to a nitrogen, fluorine, or oxygen. Number 5 is the only molecule where a hydrogen is not directly attached to an oxygen. Instead, an oxygen is directly attached to a carbon in either these cases. Well, we write this as this way, but technically, you know, this oxygen is not attached to the hydrogen, it's attached to the carbon. So if I were to redraw this, it should have been written this way. Okay, this looks like this. So this hydrogen is not attached to an oxygen. People write both ways. This is also a correct way, this is also a correct way. But if it is, you will see a hydrogen right next to an oxygen. In all the cases, there's a trend, right? So the take-home message here is, in the next video, we're going to summarize everything we've learned in intermolecular forces as far as hydrogen bonding, ionic bonding, and covalent bonding and non-polar covalent bonding. Okay, we're going to summarize all of them with one large example, which would kind of make things more sense. Okay, so water actually has 2 hydrogen bonding. Okay, just so you know. All right. So I'm going to stop this video here because all I wanted to really showcase here is, when do we know a molecule has hydrogen bonding, or when does a molecule does not have hydrogen bonding? And if a molecule has hydrogen bonding, if it has 1, 2, 3, what implication does it have on the boiling point? Similarly, you know, most hydrogen bonding means it will have, again, the highest freezing point. What does that mean? That is, it will lower the freezing point to the most negative, okay? That is, if you add methanol over glycerol to water, glycerol, this is glycerol, glycerol would have the most negative freezing point over methanol. That is, this could be -10, this could be -5. Okay, so this is much more negative. That's what I meant by highest freezing point, okay, which is more negative. Okay, all right, so I'll see you back with another video where I summarize some of the intermolecular forces. All right, stay tuned.